Today we're going to be talking about special right triangles, and with the special right triangles we're going to be talking about two different scenarios. One of the scenarios is when our triangle has angles of 45, 45, and 90 degrees. The other one is when your triangle has angles of 30 degrees, 60 degrees, and 90 degrees. So when we begin and start talking about the 45, 45, 90 right triangle, in the picture that we have, you can see that they've made a table for us and they want us to run through what happens when we have different sides of the legs. So let's start with the sides of 3 on the legs, and you remember the legs are the two congruent sides. So if we were to put 3's on both of the legs and put an X on the hypotenuse, we would be able to use Pythagorean theorem to solve for that X. So we're going to go through and do this. So we have 3 squared plus 3 squared equals x squared. So that's 9 plus 9 equals x squared. 18 equals x squared. And then we know that we put the square root in there to get the x alone. So we essentially end up with x equals plus or minus the square root of 18. And then when I simplify the square root of 18, I'm only going to take the positive answer because you can't have a negative side length, and I'm going to get radical 9, radical 2, which we know then will give us that x is equal to 3 radical 2. So essentially, when the two legs are 3, our hypotenuse will become 3 radical 2. And some of you right now may kind of notice a little bit of a pattern. So I'm going to go on to the next leg that they're showing us, which is a leg of 4. So instead of the 3's being here, I'm going to go in and turn them into 4's now. And I'll cross this out because we're going to move on. So if I do Pythagorean theorem, I would have 4 squared plus 4 squared equals x squared. So 16 plus 16. And then just like we did on the other one, if we want to get x alone, we have to put the square root in. And remember, when we put the square root in, we have plus or minus. And in this case, because we're talking about the side of a triangle, we would only want the positive answer, so we don't use the negative one. So if the legs turn out to be both 4's, what ends up happening is our x value is 4 radical 2. Which means now we can probably go through and see the pattern. Whatever the legs are, the hypotenuse is that number times radical 2. So if I work my way through here, if I had done Pythagorean theorem with sides of 5, it would have given me 5 radical 2. If I had done Pythagorean theorem with sides of 6, it would have given me 6 radical 2. If I had done Pythagorean theorem with sides of 7, it would have given me 7 radical 2. So there's a pattern on what it is that happens when we have a triangle and the sides are the legs and the hypotenuse will always be whatever that leg is times radical 2. So we're going to go ahead and generalize that idea. And in the text box that you see here, they have a 45, 45, 90 triangle drawn. And we already know that if two angles are equal, the sides across from them have to be equal. So whatever one of them is, let's call it A, the other one has to be A also. And based on what we did on the previous side, we know then that our hypotenuse, which by the way is across from the right angle, would have to be A radical 2. If we filled it in with words, which is what you see over here, we would say that the length of the hypotenuse is radical 2 times the length of whatever the leg is. And in this case, we're calling the leg A. And they give us another example over here. And in this example, our two legs, which is our A value to fit the rule, are the same. They're both 8, which means then that our A radical 2 side would be 8 radical 2. So the process is very easy. You just have to pay attention to whether you're working with the legs or the hypotenuse. So in question number 1, I have a 45, 90, 45. There was a missing angle, but we know we can add them up to 180 and find out that the missing angle is 45. So we now have two equal sides because we have the two equal angles, which means if this side of A that's across from the 45 is 6, then across from the other 45 must be a side of 6, which means that the x that we're looking for right here is going to be 6 radical 2, because it's always whatever the legs are times radical 2. Question 2 has you working backwards. They're actually giving you the hypotenuse, so they're giving you the a radical 2 side, which means then that because these two sides are equal, this is a 45, 45, 90 triangle, and our pattern will apply. And in this case, A is technically 5, which means in our situation, x is 5 on both of those two sides. When we get to question 3, it's a little bit different because the radical 2's are actually on the side of A. That can be a little bit confusing. You want to remind yourself that your A value in this case is radical 2. I know it's a 45, 45, 90 triangle because I've used 90 degrees here, and these two sides are given to be the same. They're both 9 radical 2. So when I go to find the length of the hypotenuse, I have to take my A and multiply by radical 2. Please remember, A is a number that has a radical 2 in it, so this will be 9 radical 2 times the radical 2. So A is 9 radical 2, and we're multiplying by another radical 2. So this is 9 times radical 2 times radical 2 is 2, which will end up giving me 18. So my final answer on that question for x is going to be 18. When I move on to question 4, in question 4, this time the side of A is being given as 7 radical 5, which means across from the other 45-degree angle, I'm also going to have a side length of 7 radical 5. And then for the hypotenuse, we know that that's the side where we take whatever A is and multiply it by radical 2. A is 7 radical 5 that I'm multiplying by radical 2. So this becomes 7 radical 10. So our missing side of x in this case is 7 radical 10. In question 5, they're telling us that the hypotenuse in this case in our 45, 45, 90 triangle is 12. That is the a radical 2 side. So 12 is equal to whatever a radical 2 is. So my job is to find this side of x, which we know is our a side for our pattern. So if I need to get a alone back here in this equation, it means I'm going to have to divide by radical 2. So a will be equal to 12 over radical 2. And you know we're not allowed to leave our radical in the denominator, so I have to rationalize this. So I'm going to multiply by radical 2 over radical 2, which gives me 12 radical 2 over 2. Radical 2 times radical 2 is 2, which then will give me 6 radical 2. So my side of x will be 6 radical 2 here as well as here. In number 6, they're giving me in this case the a radical 2 side again. So in this case, a radical 2, because it's the hypotenuse, is always a radical 2. What I know then is I have to get a alone because this side is technically a. So x and a are equal. So I want to divide by radical 2 to get a alone. A will be equal to 18 radical 3. So this missing side is 18 radical 3. This side here would be 18 radical 3 as well. So sometimes we have to work backwards based on what they give us. Takes a little bit of getting used to with these problems. You may need to watch the video a couple of times to see the pattern. We're going to move on to the 30, 60, 90 triangle now. And in the 30, 60, 90 triangle, you'll notice that all 3 angles are different, which means all 3 sides are different. And here's how the pattern goes. The side across from the 30-degree angle will be your A side. The side across from your 90-degree angle, which is the hypotenuse, will be double that A. So if A was 5, 2A would be 10. And across from your 60-degree angle is whatever A is times radical 3. So there's a little bit of memorizing in here that you're going to have to go through and do. In the example problem, across from the 30-degree angle is your side of A. So they're telling us A is 8. Across from our 90-degree angle is 2A, and they're telling us that's 16. That makes sense because it's 2 times 8. And then across from our 60-degree angle is our A radical 3 side, which makes sense because if A is 8, then this side has to be 8 radical 3. So let's take a look at a couple more examples on this. When we look at question 7, across from the 30-degree angle, they're telling me is 21, that's my side of A. Across from the 90-degree angle, they have labeled as X, and that is our 2A side, which is 2 times 21, which is going to give us 42. And across from our 60-degree angle, they've got labeled as Y. We know that that's A radical 3. Our A was 21, so the length of this side then is going to be 21 radical 3. So we're working the pattern here. We have to make sure we're paying very close attention to what they give us and figure out the pattern. In question number 8, they're giving me this side of 10. That's across from the right angle, so that is the 2A side. So if 2A is equal to 10, then what that means is across from the 30-degree angle, which has to be here if the angles have to add to 180, across from the 30-degree angle, the side is the A side. And if 2A is 10, then that means A is 5. And if A is 5, then across from the 60-degree angle, that's our Y, it's going to be 5 radical 3 because the rule is that it's A radical 3. When I go on to question 9, the side that they give me is across from the 60. That means that when they tell me that that's 15, that's the A radical 3 side that's equal to 15. I need to figure out A, so I'm going to divide both sides by radical 3. So A is equal to 15 over radical 3. We know that we're not allowed to leave a radical in the denominator, so we have to rationalize it. And when we go through and do that rationalizing, we end up with 15 radical 3 over 3, which gives me 5 radical 3. So A, which is across from the 30, and I know 30 is here because the angles have to add up to a 180. This X is our A side, which is 5 radical 3. And to get the 2A side, which is across from the 90, the Y that's there is equal to 2 times A, which is 2 times 5 radical 3, which is 10 radical 3. So this is all about the pattern. You can watch me do this 100 times, but you have to have that pattern memorized in order to be able to solve these kinds of problems on your own. When we flip over to question number 10, in number 10, they're giving us some information. They're telling us that our triangle here is equilateral. We've talked about that. That means we know that all 3 sides are the same, but it also means that we know that all of these angles that are in here are 60. They are telling me that there's an altitude in the triangle. An altitude goes from one vertex across to the opposite side at a perpendicular, and they're telling us that that is 7 radical 3. So when I'm looking at this, one of the things that I notice, and I don't know if you'll notice this on your own, is that if I was to focus on this triangle right here, that triangle happens to have a 90-degree angle, a side of 7 radical 3, a 60-degree angle, and therefore a 30-degree angle. If I pull the yellow triangle out and I look at it separately, what I see is that across from the 60, there's a side of 7 radical 3 That's our A radical 3 side that falls across from the 60. That means that A, which is across from the 30, has to be 7, which also means that across from the 90, our 2A side, then 2 times 7 is going to be 14. So this side here is 14, which means that this side is 14, and in our equilateral triangle, this is 14, and this is 14. So when they ask me in this question for perimeter, it means I'm adding up all the sides. That's 3 times 14, which is going to give me a perimeter of 42. In question 11, it's the area of an isosceles triangle. The vertex angle is 120. So I'm going to draw this to look like 120 with isosceles, 2 equal sides, and the legs, which are the 2 equal sides, both measure 8. And they want us to find the area of this triangle. In order to do area of a triangle, you have to know the base and the height. Right now, I don't know the base, nor do I know the height. So you may say, okay, well, how are we supposed to work with this? And in this, it's the same idea. I'm going to focus on just this one triangle right here. And this is a 120-degree angle that gets split in half by the height, so 60, 30 degrees over here. And I'm going to draw that triangle, the yellow one, all on its own over here. This is a side of 8, a 60-degree angle, a 90-degree angle, a 30-degree angle. Across from our right angle is the 2A side, which means that if 2A is equal to 8, then A is equal to 4. 4, which means our height is 4. And then across from the 60-degree angle is our A radical 3 side, which is 4 radical 3. So this side right here, 4 radical 3. When I look at the whole entire triangle, the big triangle that was originally given, if the one part along the bottom is 4 radical 3, then so is this, because the triangle is isosceles, which means the whole entire base, 4 radical 3 plus 4 radical 3 is 8 radical 3. So right now my triangle has a height of 4 and a base of 8 radical 3. So when I go back to my area formula, it's going to be 1/2 a base of 8 radical 3 times a height of 4, which gives me 1/2 times 8, 4 times 4, 16, so 16 radical 3 for my final answer. Area of the triangle, 16 radical 3. I'd like you to please do question 12 on your own. In question 12, I am going to give you a couple of hints here to get started. One of the hints that I'm going to give you is that when you draw this picture, you're going to want to make sure that it's isosceles and both of the base angles are 45. And this is the leg. So this is actually going to be your A value. And then please try number 13. And in number 13, there's technically, in this case, 3 45, 45, 90 triangles. One of them is the whole big triangle.
Miranda, please report to the main office. Ben and Miranda Malicki, please report to the main office.
So the whole entire triangle with a side of 6 is a 45, 45, 90. In addition, the triangle that's here is a 45, 45, 90 with a 6 here. And then this one over here is also a 45, 45, 90. And there's a 6 over here. The reason why I know that there's a 6 over here goes back to this triangle, the outside one, and 2 congruent sides because there's 2 congruent angles, so that makes that 6. So in this picture, there are 3 45, 45, 90 triangles. That's something that you want to pay attention to. So please try these 2 on your own and then come back and take a look at the answers. Okay, now that you're back, You can take a look at question number 12, and in question number 12, the perimeter should be 10 radical 2 plus 10. In question number 13, your y value, which is the whole stretch, should be 6 radical 2. It's divided into 2 equal parts here and here, so in your smaller triangles you can see that both of them are labeled as half of 6 radical 2, which is 3 radical 2. And then if you put your focus on this triangle that's right here, you can see the two sides are equal, so this x has to be 3 radical 2 as well.